Thank you very much.
Professor is already on the side.
Yeah, brilliant. Thank you, Jose Luis. That was a very inspiring talk and putting our research into context and highlighting why it's important we're here. My name is Patrick Henriksson. I'm from Stockholm University. And I have the honor to be here today to present the next keynote speaker, Professor Peter Tyedmers from Dalhousie University. So I've known Peter since 2008. I started my master's thesis. I was studying marine biology back then, and then my supervisor suggested I should do an LCA of aquaculture. But he also admitted he didn't know anything about LCA, but he knew this guy in Canada that was an expert on the topic. So I had a red-eye flight over to Halifax, where Peter is, and I didn't really know anything. I read a few papers. Peter was kind enough to come and pick me up at the airport, and we didn't get far from the airport before Peter entered a very inspired discussion about allocation. And at that time, being sleep deprived, it was quite overwhelming for me. But it was a very fruitful weekend. I learned a lot from Peter and a lot from his students during my time in Halifax, and I'm forever grateful about this. We have worked on many publications since, and we just finished a project called the Seawind Project. Peter has written a lot of the fundamental pieces in that little secret group that Ian was talking about earlier, the Seafood LCA people, and he's always an inspiration, and he's always good for a very vivid discussion. Unfortunately, he couldn't join us here today, so we have him virtually. But it's an honor, and please, Peter, the stage is yours.
I'm hoping that people can hear me. Am I coming through?
Yeah, we hear you.
Excellent. Thank you very much. It is a great honor to be here with you today. And thank you very much, Patrick, for the very kind words of introduction, and to Ian and the other organizers for not only putting on the conference as a whole, but thinking it appropriate to invite me to provide one of the keynotes on a topic that is near and dear to my heart, as I think Patrick was already indicating, and to many of us as well, and that's seafood systems, LCA, and sustainability. As Patrick noted, and it's very evident, I'm not with you today. It was originally my intention to be on the ground in Lima to enjoy the conference in person after the last 2.5 years, but 2 days before I was set to get on the plane, I contracted COVID. And so the pandemic continues to have an effect, and I'm doing it from a home office. So let's proceed, and I'm looking forward to the next hour that we get to spend together. Oh, and one of the things I would note is, obviously I'm still experiencing a bit of COVID, and I've probably generated more text-heavy slides than I might have otherwise because I was worried about coughing and also how it may come through. So apologies if the words do dominate at times. This is the overview of what I would like to cover today. I'd like to start with a high-level introduction to seafood consumption and production globally, because it's a corner of food systems that some of us think a lot about, but many of us don't. I then want to talk shop. I want to talk about LCA and LCAs of seafood systems over the last 25 years. And then I'll briefly turn to a slide or two to sort of speak to what can we draw from all of that diverse work. It's very difficult to do, but I'm going to try to give a little high-level sort of snapshot of where, from the existing understanding of seafood systems, their inputs, and how they contribute to high-level challenges, where they land, and how they compare amongst themselves. And then I'm going to spend the last about third of my talk talking about what I see as larger scale issues of a variety of qualities that confront us all. And I'm hoping that particularly when I speak about some of these issues, many of these same topics will resonate with our food LCA colleagues that work beyond seafood. These are not seafood specific challenges, I'm hoping. So turning first to seafood systems and how we understand them. Well, I want to start with consumption. In 2019, global seafood consumption was estimated to be at about 158 million live weight tons, and that excludes algae, which is an interesting thing for us to keep in mind. And if I don't remember to address it more formally later, maybe it can come up in conversation because it is a chronic subsystem of global food that we tend to set aside. Good news is that global production, or no, let me say global consumption of seafood has continued to increase at rates beyond population growth. So those rates of increase have declined over recent decades. This is according to the FAO, but on average recently, we're running at around 3% per annum consumption improvements over time, whereas population growth is going up at that slower 1.6% per annum rate. I've included this graph from the most recent State of the World Fisheries and Aquaculture report by the FAO, because it illustrates how heterogeneous seafood consumption is across the globe. Almost 3/4 of global seafood consumption occurs in Asia. And that is a function not just of population size and density, but also substantial differences in per capita seafood consumption between countries, regions, societies that I want to just turn briefly to now. Again, here's a table from the same SOFIA report from earlier this year. And we can see, particularly I'm drawing people's attention to the column on the far right, the sort of differences that exist between continents in terms of per capita seafood consumption, and then lower down between regions on a wealth basis. One of the things that's not evident here is the within region, or maybe I'll describe it this way, the substantial differences that exist in per capita consumption that exists between countries. So we have parts of the globe, societies where, for example, I've used Iceland, the Faroe Islands, Maldives, where citizens on average enjoy a parent consumption of over 80 kilograms per capita per annum of seafood. And at the low end, we have societies, Afghanistan, Ethiopia, Tajikistan, where apparent per capita consumption is not just far below 5 kilograms, but it may be as low as 1 kilogram per capita per year. These are enormous differences across the globe in terms of engagement with, enjoyment of, and benefits that can accrue from seafood access. And in this latter point I'm making here is I want to just turn people's attention to the 4 values in the lowest part of this table, how this apparent access to consumption of seafood does seem to vary with wealth. In many ways, this is now making me think of the former Minister Chikoma's remarks about the challenges we face internationally around food crises and addressing food insecurity issues. These issues also exist absolutely in terms of seafood and seafood access in many instances. So despite the scale of consumption globally, seafood remains a minority source of proteins in human diets. Here is a graphic that sort of provides a first high-level breakdown between animal protein and plant protein that contribute to global human protein intake. And then on the right, the subsystems of protein that are animal source proteins and how aquatic foods, I've highlighted where aquatic foods feed into that. One of the things that I would note is that this is the global snapshot. It is, sorry, I'm just going to try to move something. This is the global snapshot. It is not consistent. It would not hold for many individual countries around the world. So if we imagined Iceland or the Maldives, we'd probably see an extremely different proportion than we see here. I even think of my home country, Canada, and our neighbor, the United States. Beef, bovine meat there would massively overrepresent or outweigh the contribution in our diets from a protein intake perspective relative to seafood. The other thing that is overlooked when we just take the sort of macronutrient protein specific look at things is the important role that seafood plays in many diets, particularly diets of the poorly or undernourished. So while protein, many of the world's nutritionally challenged are in need of protein, often it's those suite of micronutrients that seafood can deliver that is difficult to gain from particularly maybe plant-heavy diets. So that's the high-level, very brief picture of global seafood consumption. I wanted to turn now to a similarly brief overview of production. And as most everyone in the room will know, and we've already heard reference to them in Minister Chiakoma's remarks, we have two big systems in the world that supply seafood: fisheries, which are very well known in Peru, and aquaculture, which is less maybe prevalent in Peru, but is very large systems now that dominate seafood production in other parts of the world. Here we have a sense of the relative contributions of aquaculture and capture fisheries to the aquatic foods available for human consumption. And we see the rise over the last 50 years of aquaculture. It now contributes the largest fraction of seafood that is consumed globally. It outstrips the seafood from capture fisheries at a global scale. Another way of looking at a similar but slightly different set of data is on the right. So this is total capture fisheries landings subdivided by marine and freshwater, stacked with aquaculture stacked above, again, marine and freshwater. If you were really sharp-eyed and quick, you might spot that the fisheries data in these two graphs are different. That is because the graph on the right includes that subset of global fisheries that do not go directly to human consumption. And from our remarks earlier about the Peruvian anchoveta fishery, we can see that that is a leading example of a major fishery that is used to underpin other food systems, aquaculture, livestock production, but does not historically or currently go to feed to people directly. And that at a global scale represents about 20 million tons a year that is not destined directly for human consumption. Those are high-level graphics with very few colors that represent enormously diverse systems. They come and they occur and they are driven by humans and technology that are enormously diverse, from both in terms of the environments, from Arctic to the tropics. They encompass not only much of of the global marine space, including deep water offshore areas where fisheries now occur, but also inland aquatic systems where we culture animals and we maintain active freshwater capture fisheries. To put it, to try to, I guess, indicate the scale of diversity, I'm not speaking here of the technologies we employ, but of the species that we utilize. According to the FAO again, over 3,100 species are landed in fisheries globally. And over 650 species are being cultured globally in aquaculture. This is a scale of diversity that massively exceeds what we see in other corners, in those much larger corners of the global food system that much of the rest of the next 3 days will talk about. And thinking about employment, following on the minister's earlier comments, seafood sectors directly employ about 59 million people, 29% of whom are women, and 90% of those women are employed in the small scale fisheries sectors. When secondary activities are included, about 600 million people depend on seafood related livelihoods across the globe. These are incredibly important systems, not only in sustaining lives, but livelihoods in all corners of the planet. But all of this occurs against a backdrop of, here I'm just going to focus on what I think of as the twin crises of climate change and biodiversity loss. We understand them well. There is nothing about the last 2.5 years of the pandemic that has dented either of the trajectories of these phenomena. On the left, I've just got some sort of very typical graphics that represent not only the Keeling curve in the upper left, the CO2 concentration in the global atmosphere, but then the more integrated, longer x-axis, integrated profile of anthropogenic greenhouse gas emissions into the atmosphere. The two maps are two imperfect, one is a map of biodiversity loss in terrestrial space. The lower right is not a map of biodiversity loss, but it's work that came out of Ben Halpern and colleagues' lab at UC Santa Barbara from 2015 that tries to collectively map the combined anthropogenic impacts on the world's oceans. And we see, so it's not a biodiversity loss map, but it is gives us a sense of the state of the scale of human interventions across the world's ocean. And of course, aquaculture and fisheries engage with, they don't only respond to and are impacted by these twin crises, but they are also contributors to them. Through habitat loss, through disease transmission, to the removal of animals, not only in directed fisheries, but to sustain many corners of the globe's aquaculture sector. We also have a long history of very well understood, but still chronically difficult to manage direct ecological impacts of fishing, whether that's in the form of bycatch that sometimes results in discards, heavy bottom contact gear in some parts of the world that fundamentally change the nature of the benthos and ultimately what can grow in there, what can live there. So we have systems that are being impacted by, but also contributing to, and in many cases driving these challenges. So that is my high level and maybe not so happy overview of seafood systems and the context within which they're occurring. Now I'd like to just turn to LCA and seafood systems and our history over the last 25 years, as it turns out, because that's a milestone. We have a quarter century of intellectual effort that has gone into understanding, better understanding, ultimately with an eye to improving how seafood systems operate across the globe. And with the help of our colleague, Friederike Ziegler, who I believe is online, she reminded me of work that she and Bette Matheson had led in the early 2000s to hold a series of meetings that revealed what I think, and I could be wrong, so I apologize if I've misremembered some of the earlier work, but some of the earliest work that I'm aware of came out of, was undertaken in Denmark as early as 1997, initially just using not dedicated software, but trying to do calculations sort of de novo in Excel before having shifted to CIMAPRO. The very first application, as I understand it, was to characterize pickled herring in a glass jar, but work by the Danes at the time at Aalborg were also trying to characterize life cycle impacts associated with cod and place fishing. One of the last slides in the slide deck that Friederike was able to share with me from 2002 that was reflecting on this earlier work by the folks at Aalborg included a slide on their big challenges or current problems. And Patrick, I am hoping you're going to enjoy this. I reproduced it here for the second item in particular. And it was a problem then, it's a problem now. It's a challenge for us all. How do we think about, how do we avoid, how do we address allocation? And that is the last thing I'm going to say on that topic today. So what has happened over the last 25 years? I'm very much beholden to a couple of my current master's students, Holly Giacomo Donato and Isaac Greenberg, for their efforts over the last number of weeks, mining the literature for their own purposes and sharing some of those with me. Of course, what I'm showing here is going to be imperfect. Any attempt to reasonably mine the literature is misses something or includes something that is inappropriate. Here, these are data that reflect papers that were pulled from Scopus, and I've subdivided them into two, those sort of primary research publications, and what I'll show in a moment are the reviews and the aggregation studies. What we see is what I was a little bit surprised, slow, steady growth, particularly of the primary literature, but not as explosive or rapid as I would have thought, particularly over the last 10 years. What we see is the literature is almost being now dominated in some years by secondary reviews, aggregation studies, people reprocessing previously published numbers in different ways, which can be extremely useful. But I do find it interesting that the foundation of so much understanding, the primary studies, is occurring, but maybe not as rapidly as at least I had thought might be happening. So that's a bit of a high-level overview of what has been going on. Oh, and the primary studies that are represented here has an N of 163, and the secondary one's 111. I just mentioned the 163 because it helps inform some of the next slides. Colleagues of mine, Robert Parker and former student Kathleen Mifflin, for work that we had been doing with our Swedish colleagues over the last few years, had previously extracted insights. So now I want to, I'm shifting our attention not to counts, but more patterns of what we have been seeing in the literature. So they had extracted data from about 125 seafood LCA papers, but not just papers that are those are reflected in that last slide, but including master's theses, unpublished PhD theses, sometimes government reports and other sources. And in combination, we've got in the database approximately 216 case studies derived from those 125, spanning 2022 to 2020. And from those, we can see some really nice patterns. Patterns in terms of geographic coverage. And here we have a map of the globe. This is all generated by, and I think broadly available through that URL at the bottom that you can see. This is a website that's driven by a database that Rob Parker has built, and we collectively are going to try to find a way to maintain. But here are the 122 aquaculture LCA case studies are mapped in terms of where the production is based. And we see not only the historic dominance of Scandinavian countries, but also the prevalence of just European aquaculture related LCA scholarship in general, and particularly in terms of aquaculture, the prominence of France. But we also have other areas of high levels of activity in Southeast Asia, or looking at or characterizing Southeast Asian aquaculture, as well as some in the Americas. Turning to the fisheries, the 94 fisheries case studies that are represented in these data, we see, again, widespread application of the tool to fisheries around the world, with a dominance, again, or a high prevalence in Northern Europe, but also Spain. So whereas almost nothing that we have, well, at least in the database, reflects French fisheries operations, we see Spain and their analyses very prominent in this. We can also look at the subsystems that are that these 125 studies have examined in their work. And here I'm using a graphic, again, generated on the website that is reflecting which of the subsystems are most or least represented. And these are very typical LCA impact categories of general application across food LCAs. These are not more tailored specific to aquaculture or fisheries. But we see that in particular in aquaculture, most LCA studies are really dominated up to the farm gate. They study feed systems and their inputs and production related. And as soon as we move beyond that, a much lower frequency is accounting for processing, packaging, storage, and storage distribution, et cetera. Which is interesting. And the other point to make here is the prevalence of feed characterization in these seafood LCAs. Why do I say that? Because over 25% of global aquaculture systems are unfed systems. So we know right away from these two images that we are seeing a over-concentration, as it were, of historical LCA research dedicated to fed aquaculture systems. I've contributed to that research, absolutely. These are fun and interesting systems to study, but we are missing a lot. Turning to what we can understand about the fisheries systems, we see a much more, I guess, one could even argue, balanced inclusion of subsystems in many of the fisheries LCAs that have been published to date, or at least reflected in the 125 that we have drawn these data from. I think that covers that, yeah. Let me now shift to, apologies. Let me now shift to insights related to the impact categories that are being reflected in these studies. It occurred to me that I actually referred to impact categories earlier, and I should not have. Those were all subsystems that were included. Here we're looking at the impact categories that are reflected in the studies, both for fish aquaculture on the left again and fisheries on the right. And we see, which is not uncommon, I think we all have a sense of this, the predominance of inclusion of global warming potential as an impact category of almost universal concern in these studies, and a much more rapid sort of dropping away of consideration of many other more traditional impact categories. What is not reflected in these two images, though, are the impact categories that we might think of as more seafood system unique or seafood system specific. And specifically, I'm thinking about something that an impact category that has been traditionally or at times referred to as biotic resource use or primary productivity required. It's not represented in either of the slides, but it does occur in 50 of the case studies that are aquaculture related and 10 times in the fisheries related cases. In a more direct ecological impact context or issue, and again, very much more of a seafood system concern, not something that would be broadly at all shared in any of the other food system LCAs, is how do these activities affect seafloor and seafloor disturbance. What is particularly striking is seafloor related impacts were included only once amongst the aquaculture studies reflected in the data here, and only 9 times amongst the fisheries cases. So really what we should take from this is much of our existing seafood LCA research has adopted the very typical impact categories that we see across food systems, with a much less frequent application of more sector-specific and potentially meaningful ecological biological impacts. So what has also been occurring in terms of the last 25 years of seafood and LCA is the rise of more sector-specific guidance. The first of these that I think of is the introduction in 2012 in the UK of the PAS 2050-2. So this is UK specific guidance around quantification of greenhouse gas emissions in seafood. It was followed the next year by the Norwegian standards publication of their carbon footprinting guidance for seafood. More recently, in 2020, we have the ISO 22949 standard of carbon footprinting for seafood that has been published. And something that many of us are aware of as is moving along, but I think is not yet formalized and finalized, is the product category rules for unprocessed marine fish that is forthcoming in the EU. So what have we learned from all of this work? Well, it's not simple to reduce all of this research, given the diversity of systems, production methods, settings, inputs, and the vagaries of the environments in which fishing and aquaculture occur, management practices, and of course, differences in how LCAs are executed. I was loath to just start pulling data out of the literature and making comparisons, but we could use what is not technically an LCA specific analysis, but draws extremely heavily on not only LCA principles, but inventory data from fisheries and aquaculture. This is a paper that was published last year, led by Jessica Gefhardt, and it appeared in Nature, called Environmental Performance of Blue Foods. And I'm just taking from their figure 1, which is looking at 5 different concerns, 3 emission sources. So here we have 5 different concerns related to aquaculture, so the farm seafood production. Here is farmed seafood contributions to greenhouse gas emissions. Here are farmed seafood contributions to nitrogen and related equivalent emissions. Here is phosphorus-related emissions. And then here in the lower right, we have farmed seafood water use and land use. The one panel that I've not mentioned is wild fisheries, and it is aligned directly underneath the greenhouse gas emissions of farmed seafood. And so this is the greenhouse gas emissions of wild-caught seafood. So these are the only two panels that are arguably maybe more directly comparable to each other. They're measuring the same things. The axes are the same. But what you'll notice are the composition of the large species groups are different in the fisheries and the farmed here. But for all of the farming systems, the organization of the groups are the same in terms of order from top to bottom. The major things to note here are the large differences between group differences in performance. Seafood, as noted, are drawn from all across the planet, thousands of species, dozens of different production modes. Not surprisingly, we see very, very different performance on a per edible weight output basis. It's also interesting how much greater, oh, and I should mention the size of the colored bars are representative of greater uncertainty in the estimates of the central point. So the outermost bars reflect the 95% sort of confidence interval. The innermost, the darkest bands are the 50th percent probability that the value lies within there. What we see is, in terms of the only basis upon which we can make a direct comparison using these results of fisheries and aquaculture are much higher levels of uncertainty associated with the capture fisheries greenhouse gas emissions than we see in aquaculture, but also very big differences between systems in both fisheries and aquaculture. The final thing to mention here is the vertical beige bands in each image as a point of reference, because it is very difficult to set an absolute sort of objective, where is a bound of what is more or less sustainable. We have used poultry as the comparator here. And so in each of the images, the vertical beige is where poultry would land. And what we see is in many of these systems, aquaculture many forms of aquaculture perform far better than poultry do. And about 50% of the large species groups that we have represented here, including some of the largest tonnage fisheries in the world, or small pelagics, including anchovies, perform extremely well from a greenhouse gas emission perspective relative to poultry. So I want to turn to what I set out to do, and that's, are we delivering on the promise of improving sustainability? I'm going to say yes, but I'm torn in saying that. We know enough to report with confidence that many seafood choices are low impact sources of animal protein in human diets. This is great news. This is great news for existing consumers of seafood and possible future consumers of seafood, particularly in settings that the former minister was referring to, where we have chronic undernutrition. And we also know that information from LCA research is absolutely affecting and positively affecting sustainability of some systems who choose to pay attention to these results and act on it, and from a consumer's perspective, because we know as we get more information into the consumer's hands, people are responding. And those are admittedly those that have the luxury of choice because of the wealth that they enjoy, but it is better for them to make change, at least as leaders. And hopefully that frees up and helps drive more change so that we can get more seafood into more people's hands and ultimately mouths. but our base of knowledge remains surprisingly narrow and is vulnerable to changing conditions and information. And I want to talk about some of those now. We have very serious gaps, but identifying them and filling them are distinct challenges. So this is turning back to some of the graphics I used earlier. Here's a map of the aquaculture, the 120 aquaculture LCA case studies that we have in a database. We see extremely little from much of the Eurasian landmass east of Europe. Very little out of Africa, except for a few countries in the north. When we contrast that to where aquaculture production occurs in the globe, so this is tonnages of aquaculture production mapped by country, we see, I think that these gaps are thrown into higher relief. Where's China? Where's India in terms of our representation of systems? If we also think about how important freshwater aquaculture systems are in the world, what we don't have is differentiation of salt and freshwater here, but so much of that Asian aquaculture is freshwater, and particularly among cyprinids, carps, almost completely unrepresented. Turning to fisheries, we still see those same geographic gaps. Now, the map of global fisheries production by country, by landing country, is a very different map with tonnages much more widely distributed across the globe. But we not only see the major gaps in terms of fisheries, LCAs in Eurasia, but also Africa, but also I would posit, look at the relatively little work that has been done on fisheries of North America. And I mean, there has been excellent work that has been done by people in the audience today on some key fisheries in Latin America, but there are many more that can be studied, particularly down the west coast of the continent. And again, I've included here a map of inland fisheries. Inland fisheries may be the most underrepresented form of seafood production in current LCAs. There is almost nothing published on them that I've been able to identify. Very well, let's say very little. So depending on our objectives, we can be more strategic about how we target some of these gaps, perhaps. For example, maybe we don't need to be prioritizing all forms of aquaculture in various parts of the world. Do we need, for example, to prioritize more, prioritize the study of salmonid culture in Asia when salmonid culture has been studied really well in lots of other places? And this is an issue that is addressed in just in part in a recent paper led by my colleague Friederike Ziegler, and that my other colleague Rob Parker will be presenting on later today at the conference in a more generalized sense. But how we think about gaps in the world of LCA and seafood shouldn't, I think, just be just an issue of location and shouldn't be just an issue of location and species. We need to be thinking about, are they very similar to things that we know a lot about, and how do we then target those true gaps in our understanding? How do I address this issue? This is a tough one because the data on it are extreme. Well, there's no data that I can really reflect on in a hard way. But even when we are keen to undertake work on a clear and potentially important gap, I've been doing this work and similar work for now 25 years. I started work on fisheries and aquaculture from an energy analysis perspective and moved with students into the LCA space. It is very, very hard to get data now. I think there's a reason, and it's not because these are uninteresting systems. I think there's a reason why we do not see a more explosive growth in the primary literature seafood LCAs than it is because it is increasingly difficult to secure high quality data from industry in particular. So this is all I can say on it. Maybe it will come up in our conversations at the end. So I want to shift to another pitfall that I see. When do we recognize that older data and results need to be retired, giving rise to the potential of gaps reemerging in our knowledge? And I think this is nicely illustrated through the role that greenhouse gas emissions associated with land use and land cover change and how they contribute to our understanding of life cycle emissions of cropping systems and hence fed aquaculture. So much of our early LCA work did not include land use and land cover change related impacts, but we continue to rely on insight from a lot of that research. But when we start to include in aquaculture LCA studies, the potential emissions from land use and land cover change, particularly for crops that are included in diets like soybeans, we can see it has a transformative effect. I'm hoping that this comes through on the screen. My apologies if it does not. This is taken, it's a figure from a report from 2020, led by Ulf Winter and a number of other Norwegian and Swedish colleagues. But this is just what I'm drawing your attention to here is the size of the orange part of the bar related to soy protein concentrate used in diets in Norwegian salmon. If you exclude land use and land cover change, you have a very small greenhouse gas, a much, much smaller greenhouse gas implication here. As soon as you include it, it changes the equation entirely. Well, what does that mean for our use of all of these historical seafood LCAs that were predicated on feed modeling that didn't include land use and land cover change? We are massively underestimating those impacts. Relatedly, we need to push others and ourselves for better data, new models, et cetera, to robustly include a host of sources of emissions and impacts that we either know or suspect are a real problem. Again, from the same report, because I was so impressed by the heavy lifting that some of our colleagues did in this work to try to move beyond the simple and the easy. This is difficult to make out, but here are basically a long list of the emission intensities of the different ingredients that were going into the farm salmon diets of Norway that they were modeling for 2017. What I'm drawing people's attention to is this blue bar near the top. That is, adjacent to it, it says pigments. What it's reflecting is the very first sort of efforts to try to quantify greenhouse gas emission intensities of providing synthetic astaxanthin, which is used to provide color to the salmon flesh. The value here is 88. The scale is 20. This is a value that is 4 times wider than can be represented in that graph. The point is that it may be a very small inclusion rate ingredient, which we have, because of its small inclusion rate, chosen to ignore. But as soon as we start to put hard numbers on this, it explodes. Biogenic emissions from ponds, methane emissions from ponds. We know that they occur. We know that they can be substantial. But our ability right now, or at least historically, to put reasonable numbers on these in an LCA frame has been very poor. And similar to the potential emissions, but not the same, that result from land use and land cover change are our disturbance of benthic sediments as a result of trawling and dredging. We have no idea right now, but people are working on this topic, as how large do our potential emissions, or at least slowing the rate at which CO2 is allowed to enter the world's oceans because of the remineralization of carbon from sediments as a result of bottom disturbing fishing. We are so far from being able to incorporate this in fisheries LCAs. And though all of these examples relate primarily to our ability to characterize global warming potential of seafood systems, we have similar scope blind spots, probably across most of the impact categories we are trying to characterize. The other thing that I want to return to is a point I made earlier, that we need to recommit to develop and implement impact categories that address biological and ecological impacts of seafood, that only 10% of fishery and, well, less than 1% of aquaculture cases that we had pulled together in this database addressed seafloor related impacts. Seems like a problem that we need to actually roll up our sleeves and address more vigorously. The last pitfall I wanted to raise, and maybe I can do this in a humorous way, and I was debating until yesterday whether to even include this or not. But I think we have a growing challenge of training and quality in the peer review process. This is entirely impressionistic. I have no scientific data-driven basis to make this observation, but there has been some remarkably poor seafood LCA studies that have emerged, particularly in recent years. For example, one that excludes the quantification of a known major driver of life cycle greenhouse gas emissions of a seafood system from their analysis, only to then conclude that the system under study had very low emissions. Or another study that treated all carbon contained in a feed consumed by fish in culture as sequestered, not recognizing that as soon as those animals ingest it, metabolize it, and other organisms in the environment metabolize those carbon molecules, it is all being re-released into the environment as respired, only to also then find that the system that they studied had far lower emissions than all prior work. It seems like a tremendous lost opportunity when we have work being conducted and published after peer review that we are getting things this badly wrong. The one thing that might be humorous is that I think the last study that I mentioned here missed an opportunity, because if it was actually true, then there is a solution to the climate crisis that would have just been to increase the feed rates of very poor quality diets to all animals in culture as a way of sequestering more food, more carbon. But that was lost on them, and well, it's a good thing too, because it's nonsense. So, in conclusion, we have enjoyed a quarter century of seafood LCA research, and more will be revealed today at the various sessions at the conference. We now understand a great deal about how seafood systems contribute to a range of important issues of global concern, and the news is generally good, at least in a relative sense. But much more needs to be achieved, including expanding the diversity of systems that we've analyzed, updating our analyses frequently, hopefully, and expanding the scope of impacts assessed and sources of impacts historically overlooked. With that, I want to acknowledge my colleagues, students, and collaborators from whom I've learned everything that I know about seafood systems. And everyone who has undertaken a seafood LCA or provided them with data. Without this work, we would know nothing. I also wanted to not just acknowledge all of the hard work of the seafood LCA community, but our forerunners, including in particular an individual. Her name was Mary Rawitcher, who in 1977, along with her supervisor, published the first major energy analysis of seafood systems, coupled with an analysis of its nutritional outputs. And this was published in Science. Just from the title alone, nutritional outputs and energy inputs of seafood, it feels as if we are effectively just carrying on the same work now as she and her colleague started 45 years ago. And then finally, I want to acknowledge all of the hard work of our organizing committee and their support staff for bringing us together and for making this possible. Thank you. And I'm done sharing now.
Thank you very much, Peter. I'm very sorry that you could not be here and enjoy the amazing seafood that we're enjoying and eat very environmentally sustainable, locally produced anchoveta. I'm going to open the floor for questions if anyone has any remarks. And please, people that are joining online, you can either raise your hand, I think, and ask your question, or write it in the chat. Yes, please.
Thank you very much for that presentation. My question is around the main concern that I understand exists around aquaculture, which is ecosystem damages, which are of primary concern, perhaps not so much greenhouse gas emissions. Could you please comment on the extent to which ecosystem damage is considered in LCA and should be considered in LCAs of seafood, please?
Let me address the second half of, it's a great question. Let me address the second half first. Should it be included? Absolutely. Is it? Not nearly enough. In part, it's difficult to do. It's difficult to reduce, as is the case in so many other of our food systems, highly localized, often very site-specific potential interactions that are very difficult to equate to other similar situations in the neighboring field, on the other side of a continent, or the other side of the world. It's very hard to reduce a lot of our ecological concerns to simple, easily commensurate measures. So this is not just a seafood LCA challenge, it's a all food systems LCA challenge. But do we do it in seafood LCAs? Not nearly enough. Has there been work proposing how we could do it better? Yes, there has, but not nearly enough. And do we need to do it? Absolutely.
Thank you, Peter. I'm going to read a question in the chat here that's a kind of follow-up on this question, and it is there also a gap in calculating, estimating the impact of biodiversity loss of fish in LCAs through seafloor disturbance? We had a session on this yesterday, but for you who weren't there, I will let Peter reflect on this question.
I'm sorry I was not there, because I would have loved to have attended any session related to how to better address biodiversity in food systems in LCA. It was the very first project that I engaged in with colleagues here at Dalhousie, was nominally to try to do a better job of understanding, to do an LCA dairy farming here in Nova Scotia that was going to then be sensitive to biodiversity. Frankly, I knew not what I was doing when we wrote that proposal, and how difficult it was and remains difficult to do. So ecological changes in biodiversity is extremely difficult because we are essentially talking about the loss of information either at a genetic level or at a population level or at a species level. And how does one add up units of information in a way that is consistent? It does a 10% loss of a highly unique species that is very vulnerable. How do we relate that to a 50% loss of the, not species, but the genetic diversity in a much larger population? These are questions that I think vex all food system LCA people and are a huge issue within seafood LCAs as well. So maybe to answer your question, do we take those into account in seafood LCAs? No, not adequately.
Thank you. And we have another good question relating to the graph you showed comparing poultry with seafood and highlighting the shortcomings of including land use and land use change in seafood LCAs. But if we would include those, do you think that seafood would compare worse with poultry? Yeah, well, so much of that, so land use and land cover change and the relative importance of that, its effect on life cycle greenhouse gas emissions of fed livestock and aquaculture is so contingent upon the source of the crop input.
So in the diagram I shared from the Norwegian analysis of farmed salmon, it was reflecting a current reasonably high dependence on Brazilian sourced soy. So much of it will also depend. So the answer to the question depends on where the system is sourcing crops, how we are accounting for that land use and land cover change. Is it only attached to and follows through to the consumers of those specific crops, or is it shared widely across all consumers of those similar crops? But under current sort of practice, no, it only carries forward. So if you did an analysis, let's say, of poultry that was based in Canada, that is not dependent on, as far as I know, very high levels of imported Brazilian soy. Canadian poultry is going to be grown overwhelmingly on a Canadian-based soy on lands that were converted into agriculture generations ago. You would not be seeing that same sort of impact. So I think it's not, so let me answer the question really tightly. If you are building chicken and fish on the same soy from the same place, both of them, and that place has a land use and land cover change impact, both of those emissions will be higher. But if they are being built on diets that are using crops from different locations with different land use and land cover change profiles, you will have, one will be impacted, the other will not.
Thank you. We're running towards the end of the hour. I can tell that the first time I had Peruvian anchoveta was at LCA Food in San Malo when our colleague Angela Vadi brought a can. And I actually brought for you, Peter, and our little community, I was bringing crayfish and shrimp cheese from Sweden to share. But unfortunately, my luggage got lost in transit, so I'm really wondering what's evolving in my bag right now. I will want to thank all the speakers this morning, and especially thank you, Peter, for taking time, even if you're recovering. And I think there will now be coffee and drinks, and I leave it at that.
Thank you all very much.